Okay, it's 1 o'clock on a Monday. Greetings and welcome. We're going to go through naming of amines and carboxylic acids today. So to flashback from last Friday, we did ethers. And ethers are never the highest priority, so they're always just a substituent. And we also did ketones and aldehydes. Ketones and aldehydes are sometimes the main chain. What are ketones called as the main chain, main functional group? Something something own, and aldehydes are something something al. And what are they called when they're substituents? So not the highest priority. Oxo, they're both oxo. All right, and then carboxylic acids are always highest priority. So those are called something something, yeah, oic acid. Those will never be a substituent because they're number one on the list, so they're highest priority. All right, amines, much like ketones and aldehydes, can be both. So what are amines called when they're the highest priority? Something something amine. And what are they called as substituents? Amino, right? So part of the reason that amines get extra complicated is because if you have a substituent on the amine, there's a different way of approaching that if the amine itself is the main chain or if the amine is a substituent. So all of that is kind of summarized in these two molecules, which are pretty complicated to name. They're also very different to name, even though their structures are almost identical. So what is going to make the biggest difference is if you find the right main chain. If you don't find the right main chain, your name is going to look completely wrong, but it doesn't mean you did everything wrong. It's just that one thing usually that you do wrong, and then it all looks bad. So don't lose heart if your name was disastrously incorrect because you just messed up the main chain. So we're going to focus real quick on just the main chain of all 5 of these, and then we'll come back and go through them one at a time. All right, so Bree, what's the highest priority functional group in this first one? The alcohol, correct. So what that tells us is that this carbon right here needs to be part of the main chain. Okay, next thing. What's the second highest priority functional group? Yeah. Yeah, the amine. So if we can, this carbon should also be part of the main chain. And then we want to have the longest carbon chain that has as many or all of the functional groups attached to it. So the longest carbon chain in the molecule would be the 6 carbons in the benzene ring, but that wouldn't include this one. All right, also remember, we cannot go back and forth between a straight chain and a ring. It either needs to be the whole ring or the whole straight chain and not both. So our chain the longest chain that includes those 2 carbons would be this one right here and the alcohol, which is the highest priority. So that's your main chain for the first one. All right, Kali, for the second one over here, what is the highest priority functional group? Right. So when you have an amine and there's carbons on both sides, you don't have a choice, but there are 2 possibilities. It could be the amine off of this one carbon or the amine off of this chain. So how would you decide? Yes. So we should be looking for the one that has other functional groups attached to it, and with all that's being said, or the longest chain at the end of the day. But this has both, so it should be the left side. So we need to have this carbon included in your main chain. So that doesn't mean that this carbon needs to be the end of the chain, just included in it. So what's the longest chain that includes this carbon right here? You can just hold up fingers. 3, right? Yeah, so it would be these 3 carbons and the nitrogen. So much like we included the alcohol in our main chain, so I circled all of that for the first chain, this one should include the nitrogen as well. So that's the main chain on this one. All right, going down here. Sydney, how many carbons in the main chain?
4.
What's the highest priority functional group? Great. So this is our main chain. Everybody got that. Most people got that one, right? All right, this one had some issues. Olivia, what's the main or the highest priority functional group? Right, so this carbon needs to be there. What's the second highest priority functional group? Well, the aldehyde or the ketone? Yes, we'll be able to get both of them, but then the third highest priority is the ketone. So our main chain absolutely needs to include this one, but should also include this one and this one if possible, and that's absolutely possible. You just do this thing. So that's our main chain. It's not the longest carbon chain in the molecule, but it's the longest one that includes the acid and the aldehyde and the ketone. All right, Caleb, what is the main chain in this one? It has a name. It's okay. What's the name of this thing? It's a benzene with a carboxylic acid. It's a benz. It is benzoic acid. So there are quite a few times when you will have a carboxylic acid attached to a number of different things. One of the ones that I talked to you about in the video was something like this, which had its own completely different name. It's a very small difference between these two if you just look at the structures. This would be a cyclohexane carboxylic acid, and this one is benzoic acid, but the naming ends up being a little bit different. The reactivity is tremendously different. So a cyclohexane and a benzene ring are very, very, very different. Make sure that you're looking for the difference. Obviously, benzene has the double bond, cyclohexane does not, but those are going to be incredibly different structures, incredibly different reactivities. All right, so those are our main chains. So any questions on main chain? Always ask yourself those two questions first. What's the highest priority functional group? And then if there's any more, what are they? And then what's the longest carbon chain that includes as many of them as possible? But it has to include the first priority. And then if possible, it should also include the second. And then if possible, also the third, et cetera, et cetera, et cetera. All right, so let's go back up here because we had a lot going on in this molecule. All right, so Savannah, what's the name of this main chain? Just the main chain here. It's okay. So, what's that? I'm having a bad day. Oh, I'm sorry. So 3 carbons is a propane. And when it has an alcohol, it would be propanol. Perfect. And you do need to tell me where the alcohol is. So I skipped a step, which we will go back and do together, which is numbering. My fault. Propanol. Yes, perfect. 1, 2, 3. So 1 propanol or propan, 1 all if you want to. Okay. You ready? We're going to get the rest of this. So this thing is a benzene ring. Think of benzene like the name of a main chain. But when it's a substituent, it's called a phenyl group. We have a phenyl where? Perfect. So this is just a 1 phenyl. All right. This part over here is a little bit more complicated. And that's because you have a methyl group and an amino. So anytime you have this kind of thing and the amine is not the main chain, you have to name this as a complex substituent. So think of it as, in order, a methyl attached to an amino attached to your main chain. So we write them in that order. We would write it as methyl, amino, main chain. So this thing as a combo is in methyl amino because they're both together, but it has to be in that order. Amino methyl would mean the amine is attached to a methyl attached to your main chain. Methyl amino is a methyl is attached to the amino attached to the main chain. So we put that all in parentheses. Otherwise, you wouldn't know if the methyl was attached to the amino or to the main chain. So we put it together as a chunk. All right, so Savannah, where is this chunk attached to the main chain? Correct, so this is just 2-methylamino. And what comes first alphabetically? Phenyl or methylamino? Phenyl or methylamino? Perfect. So we got 2, open parentheses, methylamino, close parentheses, 1 phenyl. All right, so that is the name of all of the stuff. What are we missing? Chirality. So this thing has 2 chiral carbons. We're going to do our best to Do one of them in blue and the other one in green. All right, so let's do this one first. This is carbon number 1. So with R's and S's, they should go out front of the name. With E's and the Z's, because E and Z refer to specific functional groups, they only refer to alkenes, you can put them in the middle next to the name of the alkene. With R's and S's, they don't refer to one specific functional group. So a quick glance at the name shows that you've got a phenyl on number 1 and an alcohol on number 1. So you can't put the R or the S in with the number 1. You just put it up front. Okay, so oxygen is number 1 for naming priority. Is it okay if I just go through this? I don't ask you to do all of it by yourself? Okay, thanks. The hydrogen would be number 4. And then we have a carbon on both sides. So we're looking to tie break 2 and 3 right now. The carbon on the right side is attached to a nitrogen, which is a higher atomic number, so higher priority than carbon. Carbon on the left is attached to just carbons. So the carbon on the right would be higher priority. So this would be number 2 for naming. Whew. So that's my 1, 2, 3, and 4. And when 4 is in the front, 3 to 2 to 1, right? And so we would have that carbon number 1 is S. So this should be way out front, 1S. All right, we're going to do carbon number 2 in green. So this one is chiral as well. We know that because it has a wedge or a dash written on it, and it does have 4 different substituents. So that should have a hydrogen, which will of course be our number 4. Even though up left does eventually have an oxygen, we just go one step at a time. So after one step, we have a nitrogen top right, a carbon to the bottom, and a carbon to the top left. So the nitrogen would be your number 1. And then as we break the tie between this top left carbon and the bottom carbon, the top left carbon has oxygen and carbon and hydrogen. The bottom carbon just has hydrogens. So this would be your number 2. The bottom would be your number 3. So there are lots and lots of numbers written on here. Colored pencils are great for naming. Alternatively, just kind of redrawing it somewhere. So if you need to, just kind of draw it out to the side. We've got our N, we've got our H, we've got our C, we've got our C. And then just kind of keep going from there. That way you don't end up confusing yourself with lots and lots of pencil marks and numbers, because this is an abundance of 2s and 3s everywhere. It can get overwhelming. All right, so 4 is in the back, which is where we want it to be. So now we just draw our arrow from 1 to 2 to 3. That is also S, yes. So it's 1S, 2S, 2 methylamino, 1 phenyl, 1 propyl. You cannot use trans. We can only use trans when we're talking about a ring or a double bond, because rings and double bonds can't rotate. So they're stuck as trans forever. A ring like this can absolutely rotate around. So there's always something in the front and something in the back, and those things can change as it spins. So you cannot use cis and trans for stereochemistry unless you have a ring or a double bond. Not in the molecule, but where those are found. So these chiral carbons are not part of a ring, so we can't do it. All right, questions on this name? That was a lot of stuff. All right, so let's move over to this one. There are some elements of this name that'll be the same as the first, but because the amine is highest priority, I've got a lot of other things going on, just different stuff going on. All right, so Bree, you're back up. Everybody gets a chance to play a lot of times today. Thank you all for coming to class. So we got the main chain circle. So where should we number this? From the top or from the bottom? From the, why? All right, so what we would look at first when we're deciding this is the highest priority functional group, which is the amine. So if you started from the top, the amine would be at number 2. If you started from the bottom, the amine would be at number 2. So we're looking for a tiebreaker. So what else is in the molecule attached to this chain? The benzene ring, right. So we just want to have now this as low as possible. So we should start with from the top. Yes. So because the amine is tied, the second most important thing is the only other thing attached, which is the benzene ring. So we would want to minimize that. So you want to start at the top. So 1, 2, 3. All right, so what's the name of our main chain? I'll spot you a probe. Okay, don't try to do all of it, just the main chain. So what is the circled part called? So we would go propane is just 3 carbons, but when we have an amine, what do we erase? Correct, the E. And we replace it with just, in this case, it's just the word amine. So it just becomes propanamine. So for most of our functional groups, you're striking the E at the very end and replacing it with something. So all for alcohol, al for aldehyde, oic acid for carboxylic acid, al for aldehyde, let's say that one, one for ketone. But for amine, it's just amine. So this is propanamine. And we need to say where the amine is, which is at 2. So you could say 2-propanamine or propan-2-amine, either one is fine. All right, so that's the main chain. Now we've got the substituents. So you mentioned this one. What's this one called? Phenyl? Yeah, so phenyl at 1. What is this little thing here? Yes, so this methyl is attached to your main chain. It's attached not to the carbon chain, but if our main chain is our 2-propanamine, it is attached to the 2-propanamine. So this is where amines get different from every other functional group that we've ever done. With an amine, not only do you have the numbered carbons along the carbon chain as possible place for a substituent, you also have the possibility of something being attached to the nitrogen. This was never true for an aldehyde or a carboxylic acid or a ketone or an alcohol. The first time it's become a possibility is for the amine. And so if we had a substituent on 1, we'd call it 1. And on 2, we would say 2. And on 3, we would say 3. But if it's on the nitrogen, we say N. So N is a location, just like carbon 1 is a location and carbon 2 is a location. So if and only if the amine is your highest priority functional group, so the amine is part of your main chain, do you have N as a possible place for a substituent? So just like this is a phenyl on position 1, Bree, this is an amine or a methyl on position N, correct? So methyl comes before phenyl alphabetically. So we would have N-methyl, 1 phenyl, 2-propanamine. And we do have chirality again. Boo. But good news, it's the same as it was over there. So the ranking for this carbon and this carbon are identical, so this one is also S. We could go through it if we needed to, but it's going to be the same. Whew. All right, questions about either of those? To me, the trickiest part is the difference in naming that methyl group if your nitrogen is in the main chain or if it's not. So as a quick reminder, on the left side, our alcohol was highest priority, which meant that the amine is not. So the amine is a substituent. So any substituent on the amine is a complex. We treat it like something on the amino, and all of this is a substituent. We didn't have N as an option because N was not part of our main chain. Hang on one second. And then back over here, the amine was part of your main chain, so N becomes a location at which you can have a substituent. Yes?
So do we only have to put the 1 in front of the S or the R or the 2 when there's more than one chirality?
Correct. It would be nice to put 2S, but that's not the way that it's done. The assumption is that if you know enough to know what an S is, you know enough to figure out where the chirocarbon is. So we just put, there's only one chirocarbon, we just slap the letter up there. All right, so these two molecules are structurally almost identical. The only difference is that one alcohol. I don't know if you know what these two things are, but this molecule over here is pseudoephedrine, and this molecule over here is methamphetamine. So if you go to buy Sudafed at CVS or wherever, they look at your driver's license and basically make sure you haven't been buying too much Sudafed, because meth can be made from Sudafed because there's just one carbon difference or one alcohol difference. So that's part of the reason. That's why, if you ever wonder why you can buy, it's cold medication, who cares? Well, that's why they care. So from a point of view of just an organic molecule, they're just structures and they're just things that we can name. But this one, I don't want to say that Sudafed has saved people's lives, because I can't imagine it has, but it's convenient when you've got a stuffy nose. Whereas meth has ruined many, many lives and many people's families. But the only difference is just that one alcohol. The way that our bodies respond to molecules that are almost identical with one tiny difference is pretty incredible. All right, so the big lesson of this class, don't do drugs, right? Sudafed is fine, I suppose. All right, so let's move down to some of these guys. This molecule is one that your brain makes and you have lots of. This is the neurotransmitter GABA. We call it GABA because that is the biochemical name for it, or the biologist name for it, but it's not the IUPAC name. So let's go through the IUPAC name of this real quick. It's pretty simple. Where did we leave off? All right, Kyle, you're back up again. You got a good one. You ready? Yeah. All right, highest priority functional group we know is the carboxylic acid. So how are you going to number it? Great. So what's the name of the main chain? Butanoic acid. Lovely. And here we have an amine, but it's a substituent, so we call it, right? And it's at, so 4-amino butanoic acid. So probably in GABA, you could guess what ABEA stands for. Great question. All right. So in the world of biochemistry and biology, when naming organic molecules, usually they don't use numbers. So basically IUPAC came along much later and said, there's too many molecules for us to have nicknames for all of them. So we need to figure out a way to formalize or make a systematic naming system. And that's what IUPAC did. But of course, these molecules have been around for a long, long time. And biochemists have been calling this GABA for many, many, many years and said, we're not taking your new IUPAC name. We're going to keep doing our own name. And IUPAC basically said, fine. And so these names like GABA are referred to as the common name. So they're kind of like the nicknames of the molecules. But they all have, a lot of them have basis in structures, and we'll get to a couple of those today. But in general, the old-timey or quote unquote common name or way of naming these is instead of numbering them 1, 2, 3, 4, they named them with Greek letters depending on the carbons next to carbonyls. So this is called the alpha carbon. It's the carbon directly next door to your carbonyl. So we've actually used that term, the alpha carbon, last semester. We were looking at that carbons next to a carbonyl are acidic. That alpha carbon, the spot next door. So that's alpha, and this is beta, and this is gamma. So that's what the G stands for. It's gamma amino butyric acid. So butyric is the old-timey way of naming it instead of butanoic, but they have something similar. So that's where GABA comes from, that is named GABA, or gamma, because that's where the amino is located. So you'll see alpha and beta and gamma show up a lot. Omega in omega fatty acids. What does omega mean? All right, you don't have to know your Greek letter. Omega is what? The first or the last letter? I'll give you a hint. Alpha is the first letter.
Last.
Last, yes. So like with fatty acids, omega-3 fatty acids, the alpha would be the carbon right next to the carbonyl. The omega is just the end. So omega-3 means there's something 3 carbons from the end. It's convoluted, but that's where that comes from. So they're not random. all is based in something. All right, that's enough of that for now. Let's move over here. Caleb, good news, you're up. It is awesome. I am sorry for this, but there is a chiral carbon. However, I don't have a wedge or a dash drawn here, so you won't be able to figure out if it's R or S, so you don't get to do that. Sorry. All right, so highest priority functional group is carbons. So how are we going to name this or number this?
So 1 far and 2, 3, 4, 5.
Correct. 3, 4, 5. So what's the name of the main chain? Benzenoic acid. Perfect. Okay, and we don't have to number carboxylic acids because the carboxylic acid will always be at number 1. The same thing was true of an aldehyde. Aldehydes have to be at the end of the chain, so the assumption would be that they would be at number 1. All right, and then what's this thing at 3? Oxo. What's this thing at 5? So this is a ketone and this is an aldehyde, but they're both oxos. So when a ketone or an aldehyde is not highest priority, really all it is a carbon, a double bond O. So that's why they have the same name as substituents. And what's this thing called on number 4? Correct. What comes first, oxo or propyl? Correct. So 3, 5. There's 2 oxos, so dioxo. Then 4, propyl. Okay, good. Questions on that one? All right. Olivia, what's this thing called right here?
Is that a, I don't know if this one is it a, it's not an isopropyl, is it?
Okay, good. So it is not an isopropyl because propyl is 3 carbons.
Yeah,
How many carbons are in this circle here?
4.
Correct. So it is iso because it does have that split end at the end.
Isobutyl.
Perfect. It's isobutyl. So this is an isobutyl benzoic acid. Does that sound good?
Sounds good.
All right. We do need to say where it is. Much like when we had these carboxylic acids that we didn't use the 1 carbon chunk as your main chain, we started numbering at the carbon next door. So we kind of had this as a pseudo main chain. The same thing is true of benzoic acid. For both of these, you would start numbering at the carbon right there. So this is 1. So whichever way you go, that isobutyl group is at number 4. We would do the same thing here. So in case you were numbering this with that as number 1, we can never go back and forth between a straight chain and a ring, so you just start on the ring. It turns out that there are different ways to name this in terms of positions, which we'll get to later on in the semester when we talk about naming benzenes and their analogs. But for now, benzoic acid is really the only one to worry a whole lot about. And we would number it starting here in number 1, so in the ring. That sound good? All right, so that's it. So those are the names of the bridges. Again, if you got all of the bridge answers completely wrong, but now you see what you're doing, need to do differently, good, that was our goal. So we tried. Hey,
I wouldn't want the other one.
which one? This one,
That one.
okay?
So are we gonna like, I'm assuming like, we're gonna have to like draw, we're gonna have to like draw it out and give us a name.
So either I will give you a structure and ask you to name it, or give you a name and ask you to draw the structure.
So if we gotta draw it out, how many people are gonna like, fill out of it?
How do you know which is which? Great question. I'm gonna give you, so the rest of today is just practicing structures. So I'm gonna give you a name, not you, but us, and we're gonna draw it. Does that sound good? All right. So it'll be similar to this. Let's say that we've got a nonanoic acid. And we're gonna have 3, 7, 9 trioxo nonanoic acid. So looking at this, you would not know whether these oxos were ketones or aldehydes. But you do know that they're C double bond O's, correct? In either case. So whenever you're given a name and asked to draw it, I would always start with the main chain. So here's your main chain. So what comes first in the name of your main chain? Yeah, the known, right? So what does this tell you? 9 carbons. So just do this first. We're going to do a 9 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to number it because that will be helpful to me. All right, so the rest of the name of the main chain, it's nonanoic acid. So oic acid is what functional group? Carboxylic acid, which should be where? 1, great. Double bond O with an OH. So that is nonanoic acid. That's my main chain. And what I need to do is add on 3 oxos. So once again, you don't know necessarily just by looking at this. The word oxo doesn't tell you if it's an aldehyde or a ketone, but you just put them on those numbers. Yeah, so you put a number, a double bond O on 3, and then also on where? Yeah. So what you just did is you technically gave number 3 a ketone because number 3 is in the middle of the chain. And you gave number 7 a ketone because number 7 is in the middle of the chain. And you gave number 9 an aldehyde because 9's at the end of the chain, but it doesn't really matter. You're just putting double bond O's on. So that's why we don't discriminate. So it does seem confusing. How do you know whether it's an aldehyde or a ketone? Well, it's just, if it's at the end, it's an aldehyde. If it's in the middle, it's a ketone. But if they're not the main chain, you don't have to worry about naming it al versus own. So it doesn't really matter. Does that make sense? It seems weird that you would have those two, but that's why they put it down. Does that sound good? Okay. So we'll try to get to a couple more of these naming or drawing the structures and the names. But as long as you do it this way, start with a name, draw the number of carbons, number them, and then just start putting things in. I find this to be a lot simpler than the other way around. All right. Any more questions on the bridge? Otherwise, we're going to new territory. Okay. All right. We have one more structure that was in the video that I didn't ask about in the bridge, which was this one right here. So I asked you guys to pause the video and try to name this. I don't know if anybody did, but if you did, great. And if you didn't, fine. We're doing it right now. So this one was in the middle of the carboxylic acid video. All right. Cindy, did you get to do one yet? I feel like everybody's been called on. We're just kind of going in a line. So tell me, what's the highest priority functional group? Great, so this carbon needs to be in your main chain. What's the second highest priority? Great, so you need one of these carbons to be in your main chain. Everybody good with that? All right, so this would be your main chain. Anybody unsure of why that's the main chain? It is okay to ask today. Today is the day you get to ask me questions. On Wednesday, I'm asking you questions. So ask.
Isn't the highest functional group, it needs to just be attached to the carbon, doesn't have to be.
Perfect. Yes. So because the carboxylic acid is highest priority, the amine is not highest priority. So if we can, we should have the amine attached to our main chain, but it cannot be circled. It's not part of our main chain. All right. So then this would be 1, 2, 3, 4. Right. Okay. So what's the name of the main chain?
Butyric acid.
Great. And what is this chunk as a substituent? 2-ethyl. Lovely. What is this chunk as a substituent?
4-ethylamino.
Right. So if we wrote it out like this, it would be impossible to tell if the ethyl was on the main chain or if the ethyl was on the amino, oops. Amino. So that's why we put it in parentheses, so you know it's an ethyl amino as one chunk. All right, alphabetically, what comes first, ethyl or ethyl amino? Yes, no letter beats any letter. So A comes before AB in alphabetization, right? Last name Johns would come before Johnson. Okay, so ethyl comes before ethyl amino. We would have 2-ethyl, 4-ethyl amino. By the way, I have never, if you do the name right and you fail to alphabetize those prefixes, I have never counted that against anybody's score for a thing. That being said, please try to alphabetize them correctly. It's the right thing to do, but there's enough things in naming for you to mess up that I don't hold that against you. All right, and that's it. Questions? Okay. All right, we're moving on to some new territory. What do we want to do? Let's do some more biochemicals. All right, here are 2 molecules from the citric acid cycle. The citric acid cycle is something you might have learned about in biology class. Yes? Great. I'm not asking you to tell me about it right now. I'm just going to give you some of the molecules in it. But look, these are just little organic molecules. Hot dog. This one has the nickname of formic acid, or sorry, fumaric acid. Formic acid would be much easier to name. Fumaric acid. And this one is alpha ketoglutarate, or alpha ketoglutarate acid. I am never going to, stop ready for a second. I am never going to ask you the biochemical names of these. I'm just telling you them right now. You don't ever have to worry about them. For this class, it's all about the IUPAC names. All right, so these are 2 molecules that you should be able to give the IUPAC names of. I'll give you a couple minutes. Try to come up with the IUPAC names, and then we will go through them together. If you guys in Zoom have any questions, just ask away. I'm here. Oh. There aren't 2 pentamines, there's 2 acids.
Just.
In front of the oats. So it becomes that. Yes, looks great. All right, 30 more seconds and then we'll go through these. All right, so Savannah, what is the highest priority functional group in alpha ketogluteric acid? Yes, the 2 carboxylic acids on the ends. So if you have 2 carboxylic acids, they're on both ends, the first and the last carbon, whatever that is. So this is going to be your main chain. So no matter which way you number it, your acids would be at 1 and 5. So that doesn't matter. So which way should we number it from? Correct. So it's the next thing, in this case, the only other thing that breaks the tie, which would be the C double bond. So what's the name of your main chain here? Yes. So dipentanoic acid would mean that you have 2 pentanes. So pentane dioic acid means you have 2 acids. So it's pentane dioic acid. Okay. You don't need to include the numbers because they're at 1 and then the end. So you can, it's not wrong, but it's not the way we do it. And then what's this thing at 2? Perfect, 2 oxide. All right, so that's perfect, good job. So the reason that this is also called alpha ketogluteric acid is because gluteric acid is the old-timey or common name for pentane dioic acid. So gluteric acid is this whole thing without that carbonyl. So what do you think alpha keto is telling you? What does keto sound most like? I'll give you a hint, it's a functional group in organic chemistry. Ketone, yes, ketone. And so this is a ketone. And alpha is the carbon right next to the carbonyl. So this is that there's a ketone at the alpha spot. So that's where this name comes from. Gluteric acid is the 1,5-pentane dioic acid, and there's a ketone at alpha. Fumaric acid, of course, is a common name that tells you absolutely nothing about the structure. It's just one to know. So Bree, you're up. What's the highest priority functional group? Yeah, the carboxylic acids yet again. Perfect. So in this case, the main chain is just the entire thing. So how long is your main chain? 4. Right, so what do you call 4? Bute, right. Okay. But it's not butane because there's an alkene, so it's butene. We'll put the 2-ene in there. And in this case, it also doesn't matter which side you number it from. You get to all the same things. So but 2-ene, then what? I'll give you a hint. You have 2 carboxylic acids. Perfect. Dioic acid. Woo. All right, but-2-ene dioic acid. So there's only one thing we're missing here, and it's that double bond has stereochemistry. So for stereochemistry on that double bond, we're going to shorthand this. Are those 2 acids together or apart? So this would be together. And this is apart. Ooh, I'll move me up there. So looking at this double bond, this carboxylic acid is down and this carboxylic acid is up. So it's a lot like this one. Do you remember if that's E or Z? No, anybody remember? E, yeah. So E is across or opposite. Z is the one that's together on the same side of the alkene. So this would be an E, butene dioic acid. Or if you wanted to, you could put the E right here, because E is referring to the alkene. Either one of those is an okay place for that. All right, questions about those? All right. Bum, bum, bum. I'm gonna give you, let's do a new page, 2 more molecules here. All right, this left one looks probably pretty tricky if you try to tackle it all at once, because there's just like carbons and then nitrogen, then carbons, then oxygen, then carbons. But go back to our original questions for main chain. What's the highest priority functional group? What's the second highest priority? And then the longest chain that is attached to both of those. All right, this one's going to involve some complex substituents, but looking at your bridge might help you a little bit. I'll give you guys about 4 minutes just to get as far as you can, and then we'll go through these together. Yeah, it's only true for that. We different with the oxygen, never any chance of all this. We need some of these facts. Yes, so 1 propane. That's the main chain. Yeah, that's perfect. That's pretty good. Wait, what's the name? Yeah, you. Perfect. Oh, you're doing it. All right, that's your main chain. I guess the first question should be what's highest priority? Yes. You can't include a second dollar because it needs to be a continuous credit. So your options are either these two packages. Yes, and it's really easy. Perfect, that's the main. Good job. All right, if you're out in Zoom right now, I'm going to give you a hint. For this first one, the amine is the highest priority. And so your main chain should include the amine, and it should either be these 2 carbons in the amine or these 3 carbons in the amine. And it's not about the number of carbons, it's about the other functional groups attached. So if we use these 3, we would have the ether attached and the amine attached. So this part right here should be your main chain. If you break it up that way, I think the molecule becomes much easier to make. All right, let's go through these so we have a little bit of time. Caleb. So this is your main chain, right? We established that everybody's good with that. So how would we number it? Left to right or right to left? Should we include the nitrogen in the numbers?
No.
We're only numbering the carbon, correct. 1, 2, 3. So what's the name of the main chain? Yeah, propanamine. And then we need a number. Because where's the amine?
1.
Correct. So that's a 1 propanamine. All right, so as a substituent, what's this thing? It is an ether, but specifically, it's 2 carbons. I'll spot you F. So ethyl would be without the L. So this was Friday stuff with F and then oxygen. So it's F-oxy. All ethers are named F-oxy, methoxy, isopropoxy, whatever it is, the oxy. And then what's this thing? Right, what comes first alphabetically? Ethoxy. So yeah, oxo is the name of the double bond O. There is no substituent that's oxy. So we got hydroxy, we got ethoxy, methoxy, but it's always with something. All right, and where would we say this ethyl is? Because it's not on 1 or 2 or 3. Correct, perfect. So we put all of this together and we have 3 ethoxy, N-ethyl, 1 propanamine. All right, Olivia, you ready? You get your second chance crack at this little thing here, but now you know it.
No, it's the isobutyl.
Perfect, so this is an isobutyl. So what's our highest priority functional group in this one? Because it's not the same as the bridge.
The carboxylic acid.
Perfect, so it needs to include that carbon. So how long is your main chain?
3.
Yes, good, so this is our main chain. I'm listening.
Butcher this name.
It's okay.
Propanoic acid.
Perfect, you did not butcher it. Propanoic acid is the name of the main chain. And we don't need a number because the acid is at number 1. All right, so in this case, what's this thing called as a substituent?
Phenolene.
Yes, and then this is the isobutyl. But in this case, we've got a complex substituent. We don't have both of those things attached to the main chain. We've got the isobutyl attached to the phenyl, and then that whole chunk is attached to your main chain. So we do this the same way we do methylamino. We write it as farthest away thing attached to nearest thing attached to main chain. So this would be called what?
Isobutyl. Phenol?
Yep, all in parentheses.
Okay.
So this would be an isobutyl phenol. All right. You do need to tell me where on the phenol is the isobutyl attached. So we're going to start at numbering here.
So 4.
Yes. So within these parentheses, you've got a phenol with an isobutyl attached at number 4. And then this whole thing is attached where on the propanoic acid?
1. 2.
2. So that's at carbon number 2 of the main chain. So that's pretty complicated, but we've got kind of this sub-naming. And if you add a substituent on a substituent on a substituent on a substituent, you just, like you do in math equations, you just go parentheses, parentheses, smaller and smaller and smaller. So this is the name of this big thing. All right, what are we missing? Chirality. All right. What'd you get, R or S? Did you do that
I
yet?
actually did not finish.
You didn't get there. That's
No.
fine. I gave you guys 4 minutes to name 2 pretty complicated molecules. That is not enough time. So we'll do this together. You're going to have your H is definitely number 4. And your methyl is the lowest priority possible carbon. So that's number 3. And which would you say is number 1? The carbon on the right or the carbon on the left?
The carbon on the right.
Perfect. Yeah, because they're both carbons, but that one has oxygens attached. All right. So 4 is in the front.
3, 2, 1.
Right. That is
4.
counterclockwise.
Count S.
Perfect. All right, so S2, open parentheses, 4-isobutylphenyl, close parentheses, propanoic acid. All right, real quick, this molecule is ibuprofen. Shorthand for butyl is Bu. Shorthand for isobutyl is IBU, and that's where ibu in ibuprofen comes from. And that's where pro comes from, and that's where fen comes from. So ibuprofen is some wacky combination of some little tiny parts of the term S2, open parentheses, 4-isobutylphenyl, close parentheses, propanoic acid, because no one wants to ask for that. But ibuprofen is something that sounds fancy, but we can wrap our minds and our tongues around and say to something. So a lot of times the drugs, their names are random, but sometimes they have something to do with their structure. All right. We only have about 2 more minutes. So I just want to show you really quickly another example of how you might be given a name and have to put it all together. But I still think that if you start with the main chain, you can do it no matter how complicated it looks. So propyl X5 ene 1 amine. So Sydney, you may or may not have time to copy all of this down, but where should we start?
The hexene.
Right, stop. Let's start right where? Start with what? One syllable.
Hex.
Great. So what does that tell us?
6.
Correct. And where would you like to number it from? You get to choose. It doesn't matter.
The left side.
Perfect. So check. So at that point, you've got the groundwork, and then you just add the stuff to it. So what's our stuff that we need to add?
The 5 is an alkene.
Okay, would it go from 5 to 4 or 5 to 6? 5 to 6, perfect. So the numbering on alkenes and alkynes is always the lowest number, so you'd go up 1. All right, check, 5-ene. What else?
There's an amine group on 1.
Correct. All right, I'm about to destroy this. Tell me what I'm doing wrong.
Need another carbon.
Yes, what I just did is I murdered a carbon. You don't have it replacing number 1, you have it attached to number 1. And the only thing left is I've got 2 isopropyls. One of them is at 3. That's easy to do, right? So number 3. And where's the other one?
Yeah,
Yeah, sorry, that looks like a W. So what's an N isopropyl?
attached to the nitrogen.
Yeah, boop, boop, bop, bop. Then just to do some bookkeeping, whenever you have a nitrogen or an oxygen in your line angle structure, if it has hydrogens attached, you need to draw them. So how many more hydrogens do I need?
Yeah.
Yes. So to me, this looks super daunting, but hex is not. And then a 5-ene is not. And a 1-amine is not. And putting on some isopropyls is not. So don't try to do the whole thing at once. Just start with your main chain, just the first syllable, and work from there a little bit at a time. How are you feeling? I hope you feel a little bit better than when we started today, but just know that practice, there's plenty of problems. Please practice them until they get boring. I know that amines are complicated, but there's 2 ways to approach them. Circle your main chains first and check them before you move on. Thanks. I'll see you in lab today or tomorrow. As a reminder, we have lab today or tomorrow. Everybody does. We'll go back to AB starting next week. So it's a little bit too late for today. If you have lab in 15 minutes, I'll see you in 15 minutes. If you have lab tomorrow, bring your retrosynthesis stuff. If you lost it, let me know and I can send it to you. Thanks. Go Bears. See you soon.
Since you said we have to attach an H for this problem, should we attach that H
It's
there,
just
or
when
does
it's
it
attached to
matter?
oxygens or nitrogens
Okay.
for line angle. So like that one, it has to be there. If they're attached to carbons, you don't have to include them. Some people like to write their aldehydes with the H. Some people don't. That doesn't.
Thank you.
You're welcome.